Welcome, class, to another wonderful section of physics in your study part. Today, in our context of covering as many topics as possible in your physics preparation for your Jamb, we'll be looking at a wonderful aspect and branch of physics, which is waves. So, generally, we know that wave under physics is covered under the aspects of picking optics and sound. So, at the moment, we are going to look at the optics aspect of waves. But first, the basic introduction with regards to the wave topic. So, what are the key things they want you to know in your Jamb examination? First up, you are to know that whenever you are defining wave, we describe wave as a disturbance which transfers energy from one point to another in a medium without the permanent displacement of that medium. I come again with the definition. We say that wave is what? Any disturbance which transfers energy from one point to another in a medium without the permanent displacement of such medium. Now, you put water inside a plastic, then you heat the plastic a little. You tend to see ripples of water form. That is actually wave pattern on the water. But one thing is key. There's no permanent pouring away of the water inside the bucket. Once the water is pouring away, then it's no longer defined under waves. So we say that wave finally is defined as the disturbance which transfers energy from one point to another in a medium without the permanent displacement of such medium. Now, having understood what wave is, then we can come into terms with the types of waves, classification of wave, majorly. Jamb wants to be sure that you understand the classification, and this is it. Whenever we are making reference to waves, you want to first and foremost understand that what? Wave is divided into two major classifications. Two broad classifications. So we have the first based on classification by mode of propagation, and we have the second one, classification by medium of propagation. So these form the two broad aspects with which wave is actually classified. Talking about first, the mode of propagation, and secondly, the medium of propagation. Now, your guess is as good as mine. What most of your teachers emphasize the most talking about this classification is based on the mode of propagation. But please note that Jamb expects you to understand the major similarities in terms of each classification. So whenever I'm giving you the mode of propagation, you want to be able to present to me if a mode of propagation can be found under the medium of propagation. This is what I mean. For the mode of propagation, we have two classifications, two sub-classifications. So whenever we pick the mode of propagation, we'll be talking about longitudinal wave, and we'll be talking about transverse waves. But whenever we are talking about medium of propagation, what comes to mind is mechanical wave. Okay, let's put this one here. Electromagnetic, waves and mechanical waves. Electromagnetic waves and mechanical waves. These are the four sub-classifications. Like I said, your teachers emphasized more on the longitudinal and the transverse wave types. And this is because you have them, you have so much under it in terms of mixing it up. Now, here is it. Whenever we are talking about longitudinal wave, Jamb expects you to know that longitudinal waves are actually waves which the direction of propagation is actually parallel to the direction of vibration of such wave. I come again. Whenever you are talking about longitudinal wave, we define longitudinal waves as waves in which the direction of propagation is always parallel to the direction of vibration of such wave. So we have that what? Over here, direction of propagation is parallel to direction of vibration. That is the key factor under this aspect. Under transverse wave, we have that what? Direction of propagation is perpendicular. That is 90 degree. That is 90 degree to direction of vibration. Not to worry, I'm going to explain in details. We have this. So, whenever we're making reference to the first aspect, we talk about the direction of propagation as being what? Parallel to the direction of vibration. And here is it. A popular example which I'm going to cite for longitudinal wave is this. Your friend in class is actually communicating with you, and all of a sudden, okay, better still, let's assume you fall in that category. You are discussing with somebody, and all of a sudden, you just know that what? You approach, oh, BC, and what happens? Immediately you open your mouth to say, oh, BC stepped back. And you are wondering, you now shift closer to talk to BC, and you see that what? BC is moving. BC, what happens? And she's shifting back away from you. Then take note that what? Longitudinal wave has actually what? Occurred. And this is it. Longitudinal wave, we expect that what? The direction of propagation of the wave is always parallel to the what? Direction of vibration. As such, a person is standing in front of you. You are talking to the person. It's expected that what? Your sound from your mouth is expected. Air molecules from your mouth is expected to what? Push the air barrier between you and the person you are talking to, such that what? It travels towards the person. So, this is the direction of propagation of the wave, the forward direction. You have that what? Air molecules are also vibrating in the forward direction. So, we have that what? Person A talking to person B. This is the direction of propagation of the wave. You want the wave to travel in this direction. Also, the air molecules carrying the sound are also moving parallel in the same direction towards the person. But here is the problem why BC is actually shifting back. When you were actually discussing with BC, BC's ear is actually attached at this position. But note, BC's nose is ear. So what happens is that what? As sound is progressing towards BC's ear, also the smell and odor from your mouth as a person is also passing through BC's nose. So BC is actually picking the odor from your mouth alongside the sound that is meant to go to what? Your ears. So BC is irritated by what? The smell of your mouth. As such, longitudinal wave is exposing the fact that what? You didn't brush your mouth in the morning before you were addressing BC. So, remember, parallel direction. The key word to note there, Jamb expects you to note, is what? Parallel. And it means the angle between them is actually 0 degree. The angle is 0. Remember, when two lines never meet, we have the angle as 0, not 180 notes. not 180, 0 degree is the angle for parallel angles. They are parallel longitudinal waves. So example will be what? Sound wave. Why? You need a medium and it moves in the forward direction. So sound wave will be typical of longitudinal wave. Talking about transverse wave, we said that the direction of propagation is perpendicular, that is at 90 degrees to the direction of vibration. And what comes to mind as an example will be a plugged guitar string. A plucked guitar string. And here is it. You have a guitar and you tend to what? Pluck it. What happens is you stroke downwards. You tend to pluck downwards. Plucking downwards, what happens is you have the wave, the vibration transferred along the lines of the string. You have that what? You are plucking downwards. You play your guitar by plucking the strings downwards. So what happens is the wave transfers along the lines of the strings. So watch this. Vertical movement of the fingers. You are using your frets. You are placing your hands on the frets to control the vibration of the string. But don't forget that what? You actually plucking the guitar downwards, up, down, creates a vibration horizontally. So, we easily can say this, that for this guy, you are having your guitar string, pardon my diagram for your guitar, not all the best, fine. So, let's assume that we have this as our guitar. We are going to have our string being plugged up, down. Up, down, up, down. But what happens is that what? The wave is transferred, the vibration is transferred along the string in the forward direction. So you can see that what? This is at 90 degrees to each other. 90 degrees to each other. As such, this is why we're saying that what? We have a perpendicular direction when we talk about what? Transverse wave. Note, it's easy to now say this. Having noted what we have as example of transverse wave, having known what we have as what? Longitudinal wave. The key words. I said the key words are one being perpendicular, one being parallel. And also, we are comparing the vibration direction with the propagation direction. Note, propagation direction as against vibration direction. What is happening to vibration? So when you are creating a summary, a key point of all what you have in your textbook or having watched this tutorial, note the keywords, because your smartness entails summarizing big things into smaller things. For waves itself, I said that the key things to note will be the fact that what? Energy. First and foremost, disturbance. Wave is a disturbance. It transfers energy from one point to another in a medium without what? Permanent displacement. So you want to note that. So these are the key things to note under the definition. Under the classification, these are the key things to note. You are comparing what? Propagation as against vibration. Propagation as against vibration. So that's what you are comparing there. When we now come under classification based on medium, we know that what? It's easy to easily pick and differentiate between the one that will require a material medium and the one that is not going to require a material medium. Electromagnetic waves are actually what? Wave types that do not require material medium for propagation. So we say no material medium required. Here, for mechanical waves, material mediums required. Material medium required under this aspect. So, what are the examples? Here now, we say that what? All, here, apart from guitar string, we say all electromagnetic waves. All electromagnetic waves are transverse waves. Note, all electromagnetic waves are transverse waves, but not all what? Transverse waves are electromagnetic waves. Don't get it twisted. Not what? Not all transverse waves are electromagnetic, but all electromagnetic are what? Transverse waves. Example of what? Electromagnetic wave will be light wave. Because light does not require material medium to what? Travel. So light can travel through a vacuum as such. No material medium is required. But whenever we pick our what? Sound wave would require what? Material medium. A plucked guitar string would also require what? A material medium. Water wave would require material medium. Without the water, we can't have the wave formed on it. As such, any wave that requires material medium would be classified under what? Mechanical wave. All waves that don't require material medium are classified under what? Electromagnetic waves. But I said something that what? All electromagnetic waves are what? Transverse waves. Having said this, now you know the key things to watch out for talking about what? Your Jamb examination with regards to the beginning part of wave. Having noted this, then you want to come to terms with what? The basic terms that are actually used under wave. Some of the basic terms you want to what? See under wave. Now, we'll go along with the first guy in terms of the terms. Why am I bringing into place the terms? It's simply because you actually need to know certain formulas under. This is where certain formulas came about with respect to the terms. So when you have an idea of what this term entails, then it's easy for you to go ahead using or solving calculations with regards to that aspect. So talking about terms used under wave. Number one is the amplitude. So amplitude is actually the value given to, let me illustrate first with a diagram. Some part of it can be illustrated using a diagram. Let's call this displacement. Usually this is in meters. Zero origin. Now imagine a wave moving up, down, up, down, up, down, here like this. One thing is this. The highest vertical distance covered is tagged the amplitude. The highest vertical distance that the wave covers is called away from the rest point. Note that. The highest vertical distance away from the rest point is called the amplitude. It's called the amplitude. So this is the amplitude. Note, not from down to this point. No. From the zero origin to the highest point. Either picking up, going upwards, or coming downwards. So if I'm to pick the amplitude downwards, I'll say from zero to this level here will be the amplitude. Not that you now pick from this down part to this up part. No. From the zero rest point, which is the zero horizontal line, to the highest point remains the amplitude. And under general wave equation, for example, you have your wave equation. We are going to alphabet A is used to denote it. I'm going to show you under the general wave equation how to pick your amplitude and how to calculate questions from there. So here is it. Aside that from this diagram, the distance from ear to ear is known as your what? Wavelength. It is also the same as the distance from ear to ear. That is called your wavelength, lambda. We say it is the distance between two successive crests or two successive trough. This point here is called a trough. Here, this point here, this highest distance, highest height here is called a crest. Crest, trough. So the distance between two successive trough is a wavelength. The distance between two successive crests is also a wavelength. Having that been spelled out, then you need to know that what? Amplitude, highest vertical displacement away from the rest position. Wavelength, the distance between two successive crests or two successive troughs. Your period. Period is the number of, is the time taken to complete what? One oscillation. Time taken to complete one oscillation. And the crucial thing to put in mind as far as this part is concerned is that period T is equal to 1 over frequency. In case you are given frequency in the question, know that 1 divided by frequency will give you a period. So have this at the back of your mind as a key formula to take note of. Or you say that capital T, which is used to represent your period, is equal to the total time taken over the number of oscillation. The total time taken divided by the number of oscillation. We have that as the period. Your frequency in itself, I can represent it in terms of your period, T. So I can say F is equal to 1 over capital T, or I'm saying that F, since it is the inverse of your period, it's going to be the number of oscillations over time taken. So N represents this part, T, small letter t represents this part. Or you say T on this part over N on this part. So there you have it with regards to this aspect here. Having confirmed this, then the last part which we are going to consider will be your velocity. And understanding that velocity is actually V, and it is the product of your what? Frequency and wavelength. So this goes a long way talking about this aspect. Now you understand and you're familiar with basic terms used under what? Your waves. The next aspect we'll concentrate on will be the general equations of waves. The general equation under wave. And this is what I would always pick as the general equation of waves. So we pick this. Y is equal to A sine whichever aspect you're having, WT plus or minus KX, depending on what sign you have there. So you can have the positive direction for X, that is a wave going in this direction, or a wave going in the opposite direction. That's why we have plus or minus. Now, any value you are given in the question, check. For every value given, as long as the value